Welcome to my algebra class. We are on chapter 5, section 6. We're working with another product of two binomials. This time the binomials are identical, and what happens is we get what we call a perfect square trinomial. We get a trinomial, three terms. So if I take a plus b quantity squared, that's to take a plus b times a plus b. And when I do first terms, I get a squared. And outer term I get AB, inner term I get another AB, and last terms I get positive b squared. So these two middle terms are repeated, and that's why it always comes out to be the first term squared, the middle term is twice the product of these two terms, and the last term is squared. It also works with a minus b, so first term squared is a squared. Outer term is negative AB, inner term negative AB, so I get 2. The two middle terms are the same, so I get negative 2AB. And the last term is plus b squared, negative b times negative b. So when you have this kind of multiplication problem, it will always come out to be a trinomial. The first term will be the square of the first term in the original problem. The middle term in your answer will be twice the product of these two terms, and then the last term in your trinomial is the last term squared. So I can actually do these problems without showing any work. So my answer should be the first term squared. Take the product of these two, that's negative 7x, double it, it's negative 14x, and the last term, negative 7 times negative 7 is squared, it comes out positive 49. And I can do FOIL and prove that. So it's x squared minus 7x minus 7x plus 49. And there's my negative 14x. So you're to learn how to do this. Recognize that you will get a trinomial. And the first term here is squared, 4p squared. The middle term, take these two and multiply them together, you get negative 10pq. Double it because there's two of them, so that'd be negative 20pq. And the last term, square it, always positive, 25q squared. Here's another example. First term is squared, 9u squared. The middle term is to multiply these two together, that's negative 30u squared. Double it up, so it'd be negative 60u squared. Last term, negative 10 times negative 10 is plus 100. You can always double check by using FOIL. Now going the opposite direction, we can factor a trinomial if we see that it's a perfect square trinomial. So what I do is check the first term and the last term and see if it's a perfect square. And if it is, we're going to try and see if it's a perfect square trinomial. So I set up the two factors. Take the square root of the first term, that's x. The square root of the last term, which is 3. Now remember the sign is going to be the same between them. See, I see a negative 6x, so I know it's going to have to be a negative for both of them. And then I just check. Negative 3x, if I multiply these two together, I get negative 3x. Is the middle term twice that? It is. So my answer is x minus 3 quantity squared. Second example, 9t squared is a perfect square and positive 1 is a perfect square. Remember, it has to be positive. Perfect squares are not negative. So I take the square root of 9t squared, which is 3t, and the square root of positive 1, which is 1. I see the sign in the middle term is negative, so they would both have to be negative. I multiply these two together, I get negative 3t. However, the middle is not double that, so I say not a perfect square. You can use NPS. And on the last example, a 4c squared is a perfect square, so I use 2c. And 9 is a positive, 9 is a perfect square, so I have a 3 and a 3. I times these together, I get 6c. The middle term is twice that, so it is a perfect square trinomial, and they're both negative. I can shorten it and write it 2c minus 3 quantity squared since they're both repeated twice. If you would like to copy down the vocabulary at this time, it's here on the screen. You can pause me. And I'll assume you made that decision, and we'll move on to the evens. We're on 210, and we're doing problems 1 to 42. Problem number 2. We have a quantity z plus 8 squared. I expect you to learn how to do this, so we're just going immediately to the answer. First term is squared. The middle term is twice the product of these two. That's 8x. So I times that, it's 8z, so I double that up, and that's 16z. Last term is plus 64. Problem number 4, I have p minus 10 quantity squared. First term is squared. Middle term is twice the product of these two. That's a negative 10p by multiplying, so the middle has to be negative 20p. And last term is positive 100. Negative 10 times a negative 10 is positive 100. Problem number 6. 6c minus 1 quantity squared. First term squared. 6c times 6c is 36c squared. Product of the two terms here in the binomial is negative 6c. Double that up, it'll be negative 12c. And the last term, negative 1 times negative 1 is positive 1. Problem number 8. We have 3y minus 8 quantity squared. First term, square it. 3y times 3y is 9y squared. Middle term for the trinomial, multiply these two terms together, you get negative 24y. Double it, because there's two of them. So that'd be negative 48y. And negative 8 times negative 8 is positive 64. Problem number 10, I have 4u plus 7b quantity squared. First term, square it, 16u squared. Multiply these together, I get 28uv. Double that up, 2 times 28 is 56uv. Last term, 7b times 7b is positive 49v squared. Problem number 12, 5a minus 8z quantity squared. First term, 5a times 5a is 25a squared. Multiply these two terms together, you get negative 40az. Middle term has to be twice that. So that's negative 80az. Last term, negative 8 times negative 8 is positive 64z squared. PQ minus 4 quantity squared. First term squared, p squared, q squared. Times these together, I get negative 4pq. Double that, negative 4 times 2 is negative 8pq. Last term, negative 4 times negative 4 is positive 16. Number 16, I have negative 6rs plus s squared. I'm going to square that. So negative 6rs, squaring that would be positive 36, r to the second, s to the second. Times these together, I get negative 6rs cubed. Double that up, it's negative 12rs cubed. And s squared times s squared is plus s to the fourth. Number 18, we have negative 13u plus b squared. Negative 13 times negative 13 is a positive 169 u squared. Times these together, I get negative 13u v squared. Times that by 2, since there's two of them, negative 26u v squared. Last term, positive v squared times positive v squared is v to the fourth. And the last one in this set, negative 11t squared minus 2 quantity squared. Squaring the first term, negative 11 times negative 11 is 121. T squared times t squared is t to the fourth. Times these together, I get positive 22t squared. Times that by 2, there are two of them, so 44t squared. Negative 2 times negative 2 is positive 4. Now the next set of problems, you're checking to see if they're perfect square trinomials, and then we're going to factor them. If they're not, we'll say not a perfect square. So 22, write the problem down. We have x squared minus 4x plus 4. First term is a perfect square and the last term is a perfect square, so we're going to assume we can factor it. The square root of x squared is x. The square root of 4 is 2. I look at the product of these two, it's 2x. I look at the middle, that's 4, that's twice that, and they're both negative. So my answer is x minus 2 quantity squared. 24, a squared plus 16a plus 64. Checking to see if it's a perfect square trinomial. A squared is a perfect square, so I'll take the square root of that, which is a. 64 is a perfect square, that's 8, square root of it. Check the middle, I have 8a, and 16 is twice that, so it is a perfect square trinomial, and I have to have a plus sign there, since the middle term has a plus sign. So it's a plus 8 quantity squared. 26 is 144 plus 12y plus y squared. 144 is a perfect square, it's 12. Square root of it's 12. Y squared is a perfect square, the square root is y. If I add the two middle terms, I get 12y, and if I check this middle, it's not twice that, so it doesn't work. It's not a perfect square. (28), I have 9 plus 16c squared minus 24c. Now I have a problem here because I don't have it in order. It either has to be increasing order or decreasing order based on the exponents. So I'm going to have to rearrange this so I can see if it's a perfect square trinomial. So I put 16c squared first, minus 24c. Notice that the variables are decreasing. Plus 9, that's c to the 0. So it goes 2, 1, 0. Now looking at the ends, I can see they're perfect squares. Square root of 16c is 4c, 16c squared. And the square root of 9 is 3. If I take 4c times 3, I get 12c. And I see that negative 24 is twice that, and it's negative. So it is a perfect square trinomial, and I can rewrite it as 4c minus 3 quantity squared. Problem 30, I have 49a squared plus 29ab plus 4b squared. And this is in order. It goes a squared, a to the first, and then a to the 0. There's no a. So this is ready to check out. 49 is a perfect square. A squared is, so that's 7a. 4b squared is a perfect square. That's 2b. This gives me 14ab. And the middle is 28, that's double it, and it was plus. So I have a perfect square trinomial, 7a plus 2b quantity squared. And the last one of this set, 32, I have 9u squared plus 30ub plus 100v squared. Checking to make sure it's in order, u squared, u's are the first, no u. That's okay. 9u squared is a perfect square, and so is 100v squared. So we're going to try factoring it. Square root of 9u squared is 3u. The square root of 100 is 10, and v squared is v. And if I take 3 times 10, I get 30, but this 30 here is not double that, it's not 60, so it doesn't work. So it's not a perfect square. And the last set of problems to 42. We're doing the same thing we did the last set of the others. We're going to have to pull out the greatest common factor and see if we have a perfect square trinomial. Because to start with, you can see immediately that 3 is not a perfect square. It is in decreasing order, so we're fine. It goes 2, 1, 0. So pull out your greatest common factor. If I take out the 3, I have a squared minus 6a plus 9. Now the ends are perfect squares. I bring down the 3. I try factoring it. Square root of a squared is a. The square root of 9 is 3. 3 times a is 3a. The middle is twice that. I just have to have the minus signs in. So my answer is 3 times the quantity a minus 3 squared in the shortened form. (36) 125u squared minus 50u plus 5. Take out your greatest common factor. It would have to be just 5. So that's 5 times 25u squared minus 10u plus 1. The ends are perfect squares, so bring down your 5 and let's try factoring it. The square root of 25u squared is 5u. And the square root of 1 is 1. 5u times 1 is 5u. The middle is twice that, so it is a perfect square trinomial, and they're both minuses. Shortened form is 5 times the quantity, 5u minus 1 squared the quantity. And the last three problems, 38. We have y to the fourth minus 14y to the third plus 49 y squared. So we can take out a y squared. It's the greatest thing we can take out. So we have y squared minus 14y plus 49. The ends are perfect squares. Even though, just going back for a minute, even though y to the fourth and 49y squared are perfect squares, if you don't take out the greatest common factor to begin with, you find yourself lost in it. So always pull it out. We bring down the y squared. We factor y squared. Square root is y. Square root of 49 is 7. Checking the middle, 7 times y. This is double it, and they're both minuses. So y squared times the quantity y minus 7 squared. If you don't pull out the y squared, you're going to find it down here, and you're going to have to pull it out here. So it's better to pull it out to begin with. Number 40, we have 8u cubed minus 24u squared v plus 18uv squared. I can take out a 2. I can also take out a u, and that looks like it. So this would be 4u squared minus 12uv plus 9v squared. Looking at the ends, these are perfect squares, so bring down the 2u. The square root of 4u squared is 2u. The square root of 9v squared is 3v. 2u times 3v is 6uv, and this is twice that, so it will work, and this should be both minuses. So my answer is 2u times the quantity 2u minus 3v squared, quantity squared. And the last one, 42, we have 3x to the 8th plus 48x to the 5th plus 192x to the 2nd. We can take out a 3 and an x squared. So that leaves us x to the 6 plus 16x to the 3rd plus 64. The ends are perfect squares. So bring down the 3x squared. X to the 6th factor, take the square root, divide by 2, we get x to the 3rd. Square root of 64 is 8. If I multiply these together, I get 8x cubed, and the middle term here is twice that, so it works, and they're both pluses since there's a plus here. So my answer is 3x squared times the quantity x cubed plus 8, quantity squared. That concludes the evens. Check the answers in the back of the book as you do the problems.